started. So as you said, my name is Jarret Raim. I'm the Cloud Security Product Manager at Rackspace. So my job is basically to build products that customers use to meet the security needs for their, as part of their kind of configurations.
Oh, and I'm at Tesauro. I was a former OWASP board member from 2009 to I think 2012 or something. I don't really remember. I started the OWASP Live CD project, which morphed into WT. It's a collection of testing tools for web applications. I've been a Racker since October of 11. I work in the product security group, and we're embedded in product. And as we're doing SDLC things, we're there to, do checkpoints along the way and try to break the code that our developers have written, and then get them fixed before it gets launched, when everything works perfectly.
Part of this, of course, is the reason that when you're asking customers, you never know who's going to respond to your particular query. So I'm guessing a lot of customers don't know what the rest of these elements are. So data protection is something they can relate to. But there are obviously a lot of customers who care about your piece. One thing I've always found interesting about this study is that if you look at the way that customers get compromised, it's almost always this one, which is the one they care about the least. So from a data protection standpoint, when I go and I talk to enterprise customers, small customers, big customers on cloud or various other things, they're always interested in how they can protect their data. And so one of the things that Matt and I noticed as our former careers of security consultants was anytime you go and you look at custom developed apps, generally the encryption and key management piece of that app is pretty atrocious. And we would go and we look at these things, and in a lot of cases I can look at something and say, hey, that's not really great, you probably shouldn't do that, you should do it this way, and things are fine, right? SQL injection, cross-site scripting, they're all kind of well-known ways to solve these things. What we noticed was that there really isn't a good way to solve key management for a lot of developers, right? Like you can go and spend hundreds of thousands of dollars on an HSM infrastructure, but then you got to write a bunch of code to do it. It's not easy, it's a pain in the butt, it's expensive. And so we saw this kind of empty space in the market of, hey, there really needs to be an open source, easy way to do this. And that's really kind of how this all got started. And so Rackspace is a big proponent. How many people know what OpenStack is? Pretty much everybody in the group. Okay, so Rackspace is a founding member of OpenStack, so we decided to develop this service as part of the OpenStack infrastructure. And as you can see, like there's a couple dozen projects in OpenStack these days. Pretty much all of them have some kind of need for encryption or key management. And so what we noticed was that when you were looking at OpenStack, everybody had this idea of, oh, we're going to do all this encryption stuff, and they had blueprints, and they were really nice diagrams. And in the bottom right-hand corner, there was this little box that said Key Manager, and nobody had anything, right? It was just like, so I think you looked at code once or whatever they did, right?
Yeah, I got excited because there was actually a reference in a blueprint to a GitHub account, or a GitHub repository, and I'm like, sweet, some code, I can go look at it. So I went and I pulled it, there's a bunch of methods, I look inside the methods, all they do is throw the not implemented yet exception in Python. There was nothing. So, like, time after time, I kept seeing these in these blueprints of like, we want to do encryption in block storage, we want to do encryption in object storage, we want to do encryption in glance with the image storage. And there's this little thing of key manager and no code. And just fundamentally from a security point of view, key managers are scary things that have lots of security implications, and I don't want any of them in OpenStack, right? Because you have that many different implementations, and that many people also have to get it right. You have to review it that many times. It's just fundamentally and architecturally, it was bad mojo. And so that's kind of why we came up with this idea. Oh, custom dev. Yeah, the other thing behind this is, as a security professional and somebody who talks with a lot of developers, as a story to have with them to say, you should not put your keys or your secrets, your encryption keys in the config files. And they say, great, like, what do I do? And I go, well, I don't know, but you shouldn't do it. So don't do it, right? That's like, as a security person, that's total fail. You can't tell someone not to do something and not give them another option. It's hardly going to work. So one of the things we did with this is created a Linux-based Linux Fuse file system. Linux Fuse file system, do we get that? It's a way to make a fake file system. It looks, smells, and acts like a file system, but it's not really a file system. I created a little bit of code that does a memory-based file system, would talk out to Barbican, the API for this, pull in the key and then make it appear like it was a file. So as an application developer, you could open that file and read out the key, but it never was written to disk. And then additionally, you could also put policy around those interactions, right? If I know the key's only going to be written a few minutes after boot and only going to be read one time because the app starts up, reads the key, and it's done, I can say that key can only be written within 10 minutes of boot, and by the way, it can only be read once. And if I read it a second time, I'm not going to give the key out. In fact, I'm going to kill myself, and in the process of killing myself, send a message out to the API that says, whoa, something's wrong with me, right? Beyond that, though, that's kind of for the legacy apps, because like if you work in AppSec, there's a ridiculous number of legacy apps, so we wanted to kind of catch that use case. Now, if you're doing greenfield development, you'd be smarter to just talk directly to the API. There's no reason to do a fuse file system thing, but one of the contentions we had with this is like not everybody gets to do greenfield. And there's a ridiculous number of existing apps that will have this problem. The other thing we're looking at doing is not only holding encryption keys for keys at rest, but doing SSL and TLS keys and also provisioning, and then holding SSH keys as well. And then ideally what you'd like to see as this grows is integrations with Django, with Rails, with Spring, so that it's a configurable turn-on thing, like pull my keys from Barbican, done, right? An easy configurated item when it's built into frameworks, hopefully.
So in addition to being able to store all this stuff, Barbican can also generate most of these keys. The current code as it exists right now generates AES encryption keys. Barbican supports the use of hardware security modules on the back end to be able to kind of do that in a secure manner that you don't run out of entropy and all those types of fun things that you have to deal with. As we go down the road a little bit in the future, Barbican will get support for generating different types of keys as we go forward. So obviously TLS is pretty soon up on our list. And then SSH keys and some of these types of things are pretty easy to do, right? So in addition to kind of using Barbican as the key store, you can also use it as the place to generate keys in a way that's kind of secure, that you're guaranteed that they're kind of done well. We're also looking at doing some things around SSH key management, so you can do things like enforce that there are passwords, that they can be rotated, and some of these other types of things that are typically kind of difficult to do with SSH keys in an infrastructure. So Barbican supports 3 different interaction models that we talk about, and these are kind of, putting my product hat on a little bit, these are kind of use cases that our customers care about, right? So there are a good majority of customers who want to encrypt things because they read CIO magazine and it said encryption is good, right? And so they want to go in and they want to tick their checkbox and say, yeah, everything's encrypted, cool, right? They don't necessarily understand the depth of infrastructure that has to happen to do key management, and so they want, a provider like Rackspace or whoever it is to do it for them, right? Now, we as security professionals know that that's not a particularly secure model, right? At the end of the day, Rackspace owns the key and it owns the encrypted data, right? So, those 2 things are in the same place. If the NSA shows up or whoever shows up with a court order, we're a US company, we have to give them the data they ask for, right? And so, it's not really protecting you against much other than, like a hard drive walking away from a data center or something like that. So there's value, there's not a whole lot of value, but it does solve most of the compliance related requirements if that's really all you're in it for. So that's kind of the transparent encryption model. You can just turn on encryption. You don't worry about how it works. You don't worry about where the key is. Your provider takes care of that for you, right? So then kind of in the middle is a federated keys model, which we'll talk a little bit about here in a second, which is a way to kind of maintain custody of your keys, but delegate responsibility or delegate access to them for a particular action, right? And then finally, of course, there's on-premise where you just own your keys yourself and you do whatever you want. You never give them to your provider. And so you kind of go from easy to use but not very secure to harder to use and very secure, right? So if you look at the transparent encryption model, we kind of have this idea, customer has public facing, private facing, and Rackspace has our public cloud and our kind of private piece, right? And so in this case, Rackspace is generating and storing the key for you. And we actually put a little library, I don't know if it's gonna work, but put a little library in the consuming service. So you can, for example, like Swift or Cloud Files, which is kind of the same as S3 if you're familiar with the Amazon side of things. Right, and so you upload a file to Swift, it gets encrypted on the way, and it gets decrypted on the way out, right? So when it's written in Swift, it's encrypted, right? But you don't care how that happens. You're just sending a file to Rackspace, Rackspace takes care of it, right? And so the key is not stored in Swift, right? It's stored in the Barbican key management system. So they are separate, but they're separate inside the same company. Does that make sense? Okay. So that's kind of the easy one. So federated keys gets a little more complicated. So this is the scenario in which you want Rackspace to perform the requested action for you, right? You want us to do the encryption, right? But you don't want us to have custody of your key all the time, right? And so this is kind of an in-between model. And so there's a couple of ways that we do this. The first way is that Barbican kind of can't now, but will soon hopefully support the ability to federate. And so what you can do is you can install Barbican on your premise as a customer. You can back it up against your HSMs, right? So Rackspace doesn't have access to any of those, right? And your keys are stored in those. And then you tell Barbican, hey, my tenant, this is me, I'm customer XYZ, right? I don't want any keys stored in Barbican. Anytime you need a key, come to me and get it, right? And so what this means is that when Swift, right, says, company XYZ is trying to encrypt something, right? I need a key for that. And so it's going to call Barbican. Barbican's going to say, okay, well, for that particular company, I don't store keys. They're federated. They're going to reach out to your prem and then pull that key across, right? And what we do is we do key wrapping. So the consuming service generates a public-private key pair. It sends the public key along with the request. We send the public key over to your instance of Barbican, which pulls the key from your HSM, encrypts it with the public key, sends it back through. So even though it's passing through the Rackspace version of Barbican, I don't have access to that key, right? Only Swift does. And so Swift unwraps your key, uses it for the thing that you've asked it for, and then throws it away, right? So you are still granting the service provider access to your key, but it's only for the time needed to do that particular request, right? So it's not like it's sitting on a hard drive somewhere at Rackspace, right? We just keep it for however long we need to do the encryption, and then we throw it away, right? In addition, we support another mode of federation where the client library that we actually have in Swift talks to Barbican and gets configuration, and then says, oh, well, when I need keys, rather than going through Barbican, it'll just reach out directly to the customer's environment and pull the key from there. Then you don't have to do the kind of key wrapping stuff if you don't want to, but a lot of times customers don't necessarily want to expose this particular option, or it's a little bit harder to expose that. And so they'd like to just expose one connection to the Rackspace key manager and lock that down as much as possible, right? So kind of two different options to do federated keys. So this is a nice kind of, in-between mode between managing it all yourself, which is complicated, right? And letting Rackspace manage it, which is not particularly secure. So in this particular case, you're kind of letting us do all the work for you, but you're still managing the keys. Make sense? Also means that if you want to get rid of data on a Rackspace cloud or render it useless, just delete the key, right? And then if anybody ever tried to use it, I can't get it. Key's gone, right? That data's dead. So you now don't have to worry about things like, well, how does Rackspace do secure deletion of something that I delete, right? When I delete a server, right, where does my data go? Right? So at Rackspace, we have a bunch of documentation on how we go along behind and we zero out the disk space and all this other kind of stuff, but now you don't care. You deleted the key, you don't have to rely on Rackspace doing our job or AWS doing our job or whatever it is, that data's gone. Make sense? All right, and then of course the last one, the simple one on premise, where you just do all the encryption locally. Your key stores are all local, they're all on your hard drive, they never go to Rackspace. Right? This is obviously the more complicated model, right? But it does mean that it's the most secure in that you maintain custody of those keys and those keys never leave your prem. Make sense? All right. I was originally going to show our entire Vagrant thing, but it uses Chef, so it takes a really long time to boot up. That's handy. Oops. While this is running, because Burkshelf takes forever to run. Barbican, Rackspace, we're big fans of CI/CD, and so all of our products kind of are as fully automated as we could make them. And so Barbican actually uses Chef to provision everything. We have a Vagrant script set up, so if you want to download this and play with it, Barbican is all open source. It's out on GitHub right now. You can go play with it as much as you want. We've actually cut our final release for OpenStack Havana, which is the OpenStack release cycle that everything cut for Havana last week, right? So it is our first version, 1.0, is kind of stable and out there that you can play with. And so Vagrant allows you basically to spin up the entire environment locally. So basically what Vagrant has done, how many people are familiar with Vagrant? Most people? No? Not that many. Okay. Vagrant basically is a way to wrangle a set of infrastructure on your local box to be able to do kind of development or something like that, right? And so what you can do in this case is by saying Vagrant up, you can see how it's got these five kind of names there, right? Those are individual virtual machines that have been created on my laptop right here, right? And then Chef logs in and pulls our actual production Chef scripts down and installs Barbican exactly like we would install it in production, right? So all the configuration is the same. So you can see it's got 2 queue nodes because we run an HA Rabbit queue, and then we've got an API node and a worker node, and in this case it's just a single Postgres node because Postgres replication makes me want to cry. We're fixing that, but oh my God, is it painful. So this, by just issuing one command, Vagrant up, you get all of our code in exactly the same environment with separate servers and configured the same way, exactly like we would deploy it in production, right? So then you can bang on it and do whatever you want. So it's kind of a nice way to be able to kick the tires without having to spend a lot of time and energy getting it all set up. Right, so when you're done with Vagrant, you'll end up with this. So this is how we deploy Barbican. So we have a load balancer. In fact, in reality at Rackspace, you've got an HA pair of firewalls up front, and then you've got an HA pair of load balancers behind that, which load balance across a set of API nodes. There are a set of worker nodes for dealing with background processes. We use an HA rabbit queue to kind of handle these background processes. And then right now we're using Postgres as our database. And the reason we did that, like it's much easier for us if we use some of the NoSQL things, some of those types of things, much easier to do replication, especially across data centers. But when we kind of came down to this, we wanted something with a really tried and true security model. And a lot of the new data stores don't have that so much. So I don't know if anybody went to the Redis talk earlier today, where Redis just literally says in their documentation, yeah, we don't do security. We're just not going to do that. So that's up to you guys. And so anyway, Postgres gives us that. I will say that it's a pain in the butt. We are thinking about moving to an LDAP-based store, which would make replication a whole lot easier. I'm kind of curious what people think about that, to be honest. It's easier for rack space, right? Because I have to replicate all these keys across all these different data centers all across the world and all that kind of fun stuff. So I have unique problems in deploying a rack, but I'm not sure how many people who are deploying this locally would care. But anyway, that's what we do now. You can see the HSMs hanging off to the side. We use SafeNet Lunas, but we use PKCS to talk to them. So really any HSM should work. Although I will say that PKCS support is one of those things that everybody says they have, and then you try to use it, and it doesn't so much with the work. So you have to kind of tweak it a little bit. And then, as I said, we use Chef for all of our provisioning, and then we also use Ansible for a lot of our orchestrations. Everybody know what Ansible is? Anybody? A couple. Chef is really great at configuration management, right? It helps you get your servers up, keeps them all configured correctly. Where Chef really starts to fall down is orchestration, right? So if you really want to say, well, like say I want to do a deployment, right? I have a new version of the software, I want to roll it out. And so I want to upgrade one node, and I want to wait a while. I want to look at my error logs, I want to look at tail my logs, I want to look at my front end and see if there are any changes. Are there more 500s or things broken or various other things? And if that works, I want to do another node. And if that all works, then I'll do the rest of them kind of one at a time by creating a brand new node, right? Putting it in a load balancer and then taking the old one out, right? Doing that with Chef is incredibly painful, if not kind of impossible. So we use Ansible to kind of do those orchestrations, right? So you can run a single command and it'll go ahead and upgrade all of the things in the infrastructure, or it'll add a new node to the load balancer or remove a node from the load balancer, all that kind of fun stuff. All right.
Yes. So key storage. One of the things this is Raim's team's problem. I just get to break it when he's done. But one of the things that we ran into when we started looking at HSMs and how they store things is they really don't store a whole heck of a lot of keys. Well, relatively speaking. So even though newer ones are of 1 million-ish keys, I think, is that about right?
Yeah, the newer ones store about 1 million. The older ones, originally they came to us and they said it was like, oh yeah, we could do like 200,000.
Which, at the scale of rack, that's cute. We need way more keys than that. The other issue is, particularly for things like, and we'll talk about this in a bit when we talk about the Swift storage proxy, we're doing a key per file saved in the object store. So if you have multiple tenants with multiple files, and the rate at which files are written to Swift is ridiculous. Millions of keys, millions of files is a blip in the Swift radar, and maybe not even a blip. The model for HSMs just didn't work. We couldn't store every single key in an HSM. So what we did instead is we have a key encrypting key that's stored in the HSM, and we use that key to encrypt what is the data encryption key that gets stored in the data store for, why do I want to say? I want to say Keystone, and that's not right. Barbican. Right. I didn't name it. That's the problem. But the nice thing here is this gives us the ability to scale, because now when we did run into that issue of like, oh God, when we thought about the encryption, and you'll talk about this in a bit, when we ran into some issues about we really do need to store a lot of keys, it is no longer a problem. What seems to be a somewhat arbitrary key storage limit in HSMs is no longer a problem because we're only storing one key encrypting key for each tenant. So each customer gets a magic key that encrypts the data that goes and is stored, and then we don't have those capacity problems anymore.
Does that make sense? That's kind of a key thing that we've gotten questions on in previous talks. Yeah?
Make sure it sounds clear. The key encrypting key gets stuck into the HSM, and then it does all the work. It gets pulled out through all the other.
So the key encryption key never leaves the HSM. So the HSM generates it, it never leaves it. So what the data encryption key, when we get it from the customer, whatever the customer wants us to protect, we send that to the HSM, which does the encryption. And then if we pull it out of the database, we send the encrypted version to it to do the decryption. So we do a key encryption key per tenant, but under a tenant, you can have as many keys as you want, right? So like a single tenant could have millions or billions of keys. They're all protected with that key encryption key, which you can then rotate, or at least we want to be able to rotate it at some point. It's kind of painful, so we got to write that code. But
And tenant is in an OpenStack state equivalent to a custom.
kind of. That's how it is at Rackspace. But
It is a Rackspace,
yeah.
but that's kind of the idea.
So let's just assume that I want to implement application level encryption using your federated solution, which was applied to.
Mm-hmm.
And for that, I will need to get a key from Barbican, right? And for that, it looks like I need to pass to my application some kind of secrets, password, I don't know, certificates, whatever. So
Yeah.
the question is, when instance starts in the cloud, right?
Mm-hmm.
It's not trusted, so how do I pass initially this kind of secrets that would enable connections from my instance?
Right. So right now, Barbican uses Keystone as the identity provider, right? And so you would have to have some kind of authentication credential to talk to Keystone, which is usually a username and API key. So, we've thought about kind of ways that we can layer on some things on top of that. So we've actually looked, we're looking at something right now for doing transparent disk encryption, where when the box comes up, before it actually even boots, it reaches out to Barbican and kind of passes some information about the virtual machine that's being popped. And Barbican actually uses its privileged credentials to the rest of OpenStack to decide whether or not that was a correct thing, right? So we look at underlying, we call the admin APIs on Nova, which is cloud servers. We can call admin APIs on Swift and Keystone, which are kind of file stores and auth, right? And so that allows us to do things like say, was this machine requested to be booted by this tenant? Was that tenant authenticated correctly by a person that we trust, right? And verify some of those steps before we pass a credential, before we allow it to be booted.
You do have a concept of role, as AWS have legislation introduce this kind of role concept, meaning that like if you assign certain role, it will enable.
Right. So OpenStack does support, Keystone does support role-based access control. Right now it's pretty limited. Right now we only support admin, creator, and read-only. Obviously, we're going to make that, we're going to add to that as we kind of go forward. And so you would be able to have a role for only this particular set of credentials could, pull down keys. And then when we talk about the agent, especially like the idea was when the agent comes up, you provide your username and API key when you first install it, and then it generates its own separate authentications for each, so each agent is authenticated separately. So that way, if you manage to break one, it doesn't break all the others, that type of thing. So certainly, there's always one of those shell games, right, where it's like, okay, well, I protect this key, but I protect it by another key, then what do I do with the other key? And so at a certain point, obviously, there's going to be some level of credential there. And so in that case, the agent helps a lot because it has this idea of policy where you can say, okay, well, yes, I'm granting this machine access to it, but only under these conditions. And if those conditions aren't met, then I block access, right? And so that can give you a little bit more flexibility on how you do that. But you're right, at some point there is a credential sitting there that has access to Barbican. All right, any other questions?
It doesn't solve problems, it just moves them.
Yes, just moves them. Yeah. Anyway, so one of the other things we've talked about is having a mode for Barbican where the data encryption keys are stored in the HSM. So we don't do this kind of key encryption key model. Like Rackspace needs this because we easily will go through billions and billions of keys. Somebody who's installing this and using it locally may not need that, and they want the extra security of the data encryption keys living inside of the HSM. And so we haven't done it yet, but it's kind of on our list of things to do.
So the keys are not in the HSM, but are used in the HSM for generating the actual keys?
So the key encryption keys stay in the HSM forever.
Right, but what about like the data encryption?
Data encryption keys, like when we get a new key, right, we run it through the HSM, it encrypts it using the key encryption key for the tenant, and then we store the ciphertext in the database.
Who generates it?
So you can either pass us your own key if you generated it, or you can ask us to generate it, which means the HSM is generating the key for you. Yeah, because like one of the nice things about having the HSMs is that now I don't have to worry about things like randomness on a virtual machine and some of that kind of stuff. So in fact, one of the things we've talked about is having a resource on Barbican, completely unauthenticated, just a resource sitting on Barbican where you can just get a block of randomness, right? So if you're on a virtual machine and you want to seed your local with some random data or whatever, you can just ask Barbican for a big old block of randomness and it'll give it to you. So we'll see. So the API right now is very simple. There are only two resources. There are secrets and there are orders. So secrets is a simple CRUD way of actually just accessing, create, read, update, delete for your particular secrets, although we actually don't allow you to update them, but it's kind of a different thing. But anyway, so you can kind of see what we're talking about here, right? So you give it a name. We put expiration dates on all keys, including symmetric keys. So much like TLS, like when you get an SSL certificate, it expires. You can now put expiries on your AES encryption keys, which is very nice from a compliance standpoint. If you have this idea that a key needs to be rotated, you can just put an expiration date on it, and Barbican will cease to provide it. once that expiration date has expired, right? So obviously you want to rotate before that, because otherwise your stuff will break. But this way you can prove to an auditor, like, I expired this key, it was no longer, and obviously it's auditing and logging to kind of back that up. So we got algorithm, bit length, mode, all that kind of fun stuff. In this case, you can actually provide the payload directly. So this is a case where users are giving us the actual value of the key that they want us to store rather than asking us to do it. And then we use content types to tell us the type of thing that you're storing. So we'll store bits, we don't care, right? You want to give us a block of bits, have fun, right? But if you give us a content type that we understand, right, like a PEM file or anything else, right, then we can do kind of special stuff with that, right? It allows us to kind of wrap some functionality around it. Right, and then you can see here's a get for the key itself. So the orders resource is how you create keys. The orders resource is asynchronous, and this is something we've had some arguments with people about. And the reason we did that is that while an AES key can basically be a synchronous create, right, because it's relatively fast to create those, things like SSL certs can't be, right? So Barbican supports provisioning SSL certs from public CAs, right? So you can ask us to provision SSL cert from VeriSign if you want. Right now, we can send the data to VeriSign, but especially if you're asking for an EV cert, VeriSign's going to talk to you, they're going to want all this data, you're going to have to sign over your firstborn, and then they'll give you the key. So it might be days or weeks until you get your key out of it. So the idea with an order is that you actually put in a request for an order, right? You order a particular thing, and then when you get it back, you'll see what happens is you get the order back, and then it'll have a link to the secret that we generated for you. Does that make sense? All right, so you want to be
I looked at that part of the example. Presumably you have a status as well.
Yeah. Yeah, you can pull the order status. Here, you want to be a mic stand?
Yes, I can be a mic stand.
All right, so
Highly paid mic stand.
The demo that we decided to do today is a proof of concept that we put together, and it's a proxy server that sits in front of Cloud Files, right? So Cloud Files is an object store, and basically it implements transparent encryption using Barbican and a couple of things to kind of make all that happen for a user, right? So we wrote this this proxy server here, so you can kind of see this, it's starting up, and we've got this lovely file here that we are going to actually play with, right? So if I go into my Cloud Files account right now, Rackspace, I've got this test container here that we created, right? And right now there's nothing in it, right? So it's just an empty container that's sitting out in Cloud Files, right? So here's our, go away, Outlook, no one likes you. So here's the curl command. So this is the exact same curl command that you would send to Cloud Files. It's no different, right? So if you're using CyberDuck, you're using any other client of Swift, right, that just normally talks to Swift, this works perfectly fine, right? The client doesn't know that encryption is happening. It's entirely transparent, right? So we're going to grab this curl command here. And so you can see basically it says it's doing a chunks transport encoding. It passes in the auth token, which I put into my environment so that you guys can't see it, because I don't trust you. It has the test file source, and then it's the Cloud Files endpoint, the container, and then the file that we're actually trying to send to, right? So what you'll see is basically I'm connecting, right? Curl is connecting to localhost, right? Because that's where my proxy happens to be running, right? It's doing all this work and sending it off. And so part of the pain of creating this proxy was like being able to do chunks, right? So you don't want to send the file all the way to the proxy, do all the work, and then have the proxy send it to Swift, because Swift can have 10 terabyte files put into it, right? And so this actually streams, like it streams the file through the proxy, both front, back, and encrypts kind of as it goes. And so you can see it, you know, if we go and we look at the proxy, you can kind of see the actual target that it's talking to. In this case, it's Cloud Files. You can see the length of the data. It has to decide whether that data needs to be padded, and it does the padding as it needs to. And then you can see here's the actual encrypted value that it writes out. So now if I go to Cloud Files, we have, if Cloud Files would load, we have a file that's now been updated. Now you'll notice that the container and the file name are unencrypted, and we'll talk about that in a sec and why that is. But if I download this, then if I go and grab it, right, then what we get is garbage, right? So this is me going directly to Cloud Files, and I'm downloading the file from Cloud Files, right? So the file that's sitting in Cloud Files on Rackspace's servers is completely encrypted, right? And so then, obviously, I want my file back. So I grab another curl command, right? So in this case, it's grabbing that file as we talked about. It's doing a get this time. Again, you're passing your auth token, transport chunked, and it gives you the name of the file and all that, right? Does its thing. If you look here, Now you're seeing that it got a GET request, right? So it's going through and talking to cloud files. You see the lengths are actually different. So the length when we uploaded is 14, the length when we pulled it down is 16 because we had padding and all that kind of fun stuff to make all the encryption work. We're doing HMACs, which are totally broken right now, which is why those two things don't match. And then of course,
Not the HMAX you're looking for.
right, yeah. And then of course it dumps out the original value of the file, right? So nothing too magic. It was a giant pain in the butt to get working. But that type of thing it was a POC to kind of show how you can use Barbican to do the key management. So in the background, right, when I upload that thing, I'm taking that off token. I know what tenant this belongs to. So that code reaches out to Barbican and it says, hey, do you have a key for this? If not, then generate one. And it pulls that key down. It uses that for the encryption. We actually store the link to the key in the metadata of the file in Swift, right? So that when you pull that back out, Barbican looks in the Swift file and says, okay, this is the key, and it goes back up to Barbican, and it pulls it down and decrypts it. So all that's kind of happening in the background, and you as a user don't care, right? So the user interface for this at Rackspace would be, I would like to encrypt to take my checkbox, right? And that's all you have to do.
So, yeah, we'll go over your question, but is there any thought of like productizing something like this as a proxy? So like say you have like a CRM or something like that, and you basically have Swift or something that's posting content. It seems like it'd be possible to have it where for a customer that has that CRM solution, you can set up an on-prem proxy and then have that do decryption for you, and then whatever stored would never be unencrypted off the grid. And you can just back off to it, and you have links where you like, this is my proxy server.
Yeah, you definitely could do stuff like that, right? So, you know, I'm not sure Barbican will write that. I mean, we wrote the Swift thing because we're trying to kind of prove the concept and get people to use it. And there are some companies that are doing that for like Salesforce and some of those types of things, right? And definitely kind of nice models. And like what we'd like is that Barbican kind of becomes the back end for those things and defines kind of a nice open source kind of API that everybody can use. There's an open source reference implementation that's free that anybody can run. Now, if you want to go and pay for it, right, like the paid versions will have lots more. So we've been working with Gazang, for example, to kind of plug their stuff into this, right? And so like they offer a lot of stuff that Barbican we're just never going to do, right? Like I'm not going to write encryptfs, like that's their bag, they do that, right? And so, but we'd like this to be kind of the reference implementation for how the API works for multi-tenant stuff, right? And so we'll talk about keymip a little bit later, but you know, that's kind of what we're aiming at for this particular thing. So it's kind of insanely hard to read, but Portcullis is the name of the Swift proxy that it's our code name for it. So as we said before, we do a key per file, and the reason we do that is Swift has semantics that allow you to copy a file from container to container. And so originally we tried to do a key per container, which would mean much fewer keys. The problem is that when you copy with containers, we would literally have to pull the entire file out of Swift and decrypt it and push it all back in. So now we actually do a key per file. And so you can imagine the fact that Cloud Files has billions of objects, right? Then now you start to have a lot of keys, and you can see kind of why we like that key encryption, key data encryption model. We didn't encrypt the file and container names, and that's mostly to keep the rest of the tools that use Swift working, right? They would get really grumpy if you have just totally random stuff, and it'd be very hard to use. And so kind of we kept that. And then one thing that we did add, or we're adding, is a verify resource. So right now we're using AS256 CBC with SHA-1 HMAC. Yes. And so obviously we can't calculate the final HMAC value until the entire file has been served out, right? But we're streaming the file to the user. So there's no way that I'm not pulling the whole file, checking it, and then sending it to the user, right? I'm sending the file to them as they're asking for it, right? So that means I don't actually know that the HMAC has failed until the file is already all the way sent to the user, right? So to solve that problem, what we do is we expose a verify resource. And as a user, you pull your file down, and then you call to the verify resource, and you say, here's the file that I pulled down, and then we'll return you the value of the HMAC, right? So that way you can check. If you want to, you can check to make sure that your file hasn't been screwed with or anything like that during the process. And we will switch to using GCM just as soon as Python works for GCM, which we're also working on, but that's a different presentation.
Has there been any thought about providing, well, is it possible, and if not, has there been thought of providing access to arbitrary offsets inside the resource if you get a 2 terabyte file that's encrypted? You may want to.
So Swift does that. So Swift has the ability to do offsets. Yeah. Well, that gets to be a little interesting.
Right.
So right now we haven't done it. But you certainly could do it. So there's ways to do it by using, what is it, ASXTS, And so it's the same one that people use for disk encryption, right? Same idea that TrueCrypt uses. So in that case, the blocks no longer depend on each other, so you could just skip to the middle and do encryption from there. So definitely possible. XDS has its own kind of challenges. It's not quite as good as kind of doing the standard encryption model, but that would work, right? So it wouldn't be that hard to do.
Probably even like more important and interesting scenario is that like when you have a huge database and you encrypt in a field level, right? And then like you have a problem of purity synchronous. So it looks like in your solution, this is my responsibility to do the encryption of all the data. But there are solutions like Oracle CD or other similar, or even like appliances like Ingrium. They support like one big solution, but you don't integrate it. So you just say, okay, I got taking the key and you take care of all the calls which are encrypted using.
Yeah.
So do we integrate with like existing solution, Oracle?
So right now, no. That being said, it's something that we're talking about with them. So a lot of them will support keymip. And we've talked about opening a keymip endpoint on Barbican so that you could speak keymip to it instead of REST. And so that would allow you to back up against an Oracle database or something like that. You can also always just point your Oracle database directly at your HSM, and that will work fine too. You don't have to go through Barbican in that case unless you want to. So definitely something we've had conversations about.
So you're saying that like I can integrate Oracle CD with HSM?
Well, so like we don't have anything to do with the HSM. You buy it. We just happen to use it for our stuff. You can include it as part of the solution. So yeah, if you wanted to have Oracle talk directly to that, you could do it. It wouldn't have anything to do with us. We've also talked about, like I said, exposing a keymip endpoint that would allow Oracle to talk directly to Barbican, and then Barbican would talk to the HSM, so that would work as well. All right, so future work. So the next release of OpenStack is Icehouse, hence the reason we have an Icehouse. See, we all get it now. So kind of coming up, KMIP is a big one that we're talking about. So first we'll start supporting KMIP on the back end. So Barbican will speak KMIP to the HSM rather than using PKCS. SafeNet has gone and implemented a KMIP library in Python, which is very nice. It did not exist. They haven't open sourced it yet, so we'll see if they do that. And if they do, then we'll use it. We'll also do support for SSL and TLS. So this includes provisioning SSL certificates, both from a local CA that's part of Barbican and also from public CAs. We're going to implement Symantec first because that's what Rackspace uses. So that'll get you VeriSign, Thoughts, GeoTrust, and Rapid. And then if you want to add your own, obviously there's a plugin infrastructure to be able to do that. So that also includes lifecycle management, including notifications when certs are going to expire, all that kind of fun stuff. And then at Rackspace, we're going to implement the ability to automatically deploy some of them. So for example, if you want to deploy your SSL cert to cloud load balancers, you'll just be able to do that, and the system will reach out and kind of do that for you. The federation stuff we talked about, right? So the beginnings of the design of that is there, but we haven't started coding it, so that'll be for Icehouse. And then integrations, things like the Swift proxy and stuff are kind of some things that we're doing to help other people in OpenStack understand how to use key management. A lot of them are just developing systems that have a key in their configuration file. And so trying to get to the point where they kind of think about how to do this correctly is something that we'll spend a lot of time doing.
So if you're interested now and you want to start playing around, there are existing libraries out on GitHub for this. We have the Barbican client, right? You can just import the client. It's a Python library. There's a simple example of doing some secret store and secrets create, right, calls. And then there's also the source code and documentation is up on GitHub under the Cloud Keep organization. Blueprints are on Launchpad because that's where OpenStack does them. So if you want to see the blueprints for future development, that's where they live. And then there is an integration environment right now that's running on a public cloud server. It is not secure at all. It's just if you are writing a client or writing against Barbican and you want to make sure it works, here's something that's an endpoint that works but is strictly for dev and testing. It's not for real at all.
Not for real. Yeah.
Not for real.
The team pretty much hangs out on Freenode in OpenStack Cloud Keep. So if you ever want to hop on there, we're always on IRC. That's usually where we do most of our work. Obviously, github.com/cloudkeep is where all the code is. And we have a mailing list that no one uses, but you're welcome to hop on there if you would like to. We do all our stuff on IRC, so but the mailing list is there for those who want it. So you can hop on that and get a hold of us. So there are 4 of us now, really, that are doing most of this work. And we'll actually be going out to the OpenStack Summit next week to kind of talk about it, kind of plan out what the next 6 months is going to look like. So I think that's mostly what we have now. I mean, any questions or anything else that we can answer? Yeah.
So this is mostly about data encryption. Do you have any plans to integrate that to API signing in OpenStack?
So I think Barbican wants to be the backend for a lot of those features rather than implement them ourselves. So like what we don't want to turn into is Barbican writes all the encryption code in all of OpenStack because we just can't keep up with that kind of stuff and we don't know the sub-projects enough. But we have had a lot of conversations with API signing stuff, with message signing things across message queues, with PKI authentication, with Keystone, all these different things, all these places in OpenStack that want to do encryption. We've talked to a lot of them to make sure that we're kind of providing what they need to store and maintain all these keys, right? So the nice thing is that all of your keys in OpenStack will be in one spot, one service that's kind of, you can deploy in a much more secure fashion, you can audit it, you can get it, part of your compliance regime if you need to, has all the auditing and logging, you can create all of your RBAC rules and all that kind of stuff in one spot, and then it's just used by all the other services inside.
So what's the stage of integration with the AJAX or stuff?
So I don't think they've done much yet for the API signing stuff. So we're having a design session in Hong Kong specifically to talk about the interface between Keystone, which is identity, and Barbican. So kind of like Keystone has a lot of encryption kind of pieces to it. You can do kind of, you can authenticate with keys, you can do signed tokens, various other things. And so we're going to have a lot of conversations about what's identity and authentication authorization and what's keys and how should those interact with each other. So hopefully as we kind of nail that down, you'll kind of see a little bit more where Keystone will use us for some things and it'll use itself for some things. At the end of the day, Barbican is tied to Keystone. We use it for authentication, so they both have to be basically the same level of security for you to kind of have. If Barbican is super secure and Keystone's not, it doesn't help you that much, right? And so if they want to store something in Keystone, then that's fine. It doesn't matter too much to us. All right, any other questions, comments, concerns? All right, I think that's all we got. Thank you very much.